One of the big promises of containers is that we can easily deploy our apps like we were a platform service, like Heroku or something. But we could do that on anyone's hardware, whether it's on our hardware or it's a cloud provider, whether it's virtual or physical. And with Docker, our apps can run the same, whether they're in Amazon, Azure, DigitalOcean, Linode, Rackspace, Google Cloud, or whatever. But without all those platform features, how do we easily deploy and maintain our dozens or hundreds or even thousands of containers across many servers or instances, or nodes or droplets or whatever? So that brings to bear some really new problems that weren't previously problems for small organizations. Now, we all know about Netflix and big organizations like that scale to thousands and thousands of nodes and tens of thousands of nodes, and they've got lots of engineers. But if you have just a couple of people on your team, or if you're just a solo developer, how do you take your containers and scale them and deal with their entire life cycle, from deploying them to starting them to restarting them to recreating them to deleting them and updating them and all that? So we start to ask questions around how exactly does Docker do that, or does it even do that at all? Some of the questions we ask ourselves are things like, how do we scale out? How do we scale up? How do we ensure that our containers restart if they fail? How do we replace those containers when we actually have an update for them, which is something called blue-green deploy nowadays, which means that you have zero downtime and you take servers out of the pool in order to bring new ones in, and you end up with always something available so that you're never really down when you update. Or how do we know if we've got dozens of nodes or even just 3 nodes, where we started those containers? Which node is our container on? How do we talk across those different nodes or servers with our networking inside the containers? And when it comes to security, how do we be sure that our containers are only running on the machines that we intended for them to run on? And now that we're moving things around and deploying them dynamically on the fly, how do we store the private information we need for our containers, like secrets or passwords? So this brings us to a major evolution in the scope of what Docker tries to solve. And when people talk to me and they think that Docker is just a container runtime, that's when I actually just mentioned Swarm Mode, which is a brand new feature in 2016 that brings together years of understanding the needs of containers and how to actually run them live in production. So at its core, Swarm is actually a server clustering solution that brings together different operating systems or hosts or nodes or whatever you want to call them into a single manageable unit that you can then orchestrate the lifecycle of your containers in. And just to be clear, we're not actually talking about Swarm, which I'm just going to call Swarm Classic, which was a add-on component to Docker before 1.12 came out. And it was really a container that would run inside of Docker that really just took your Docker run commands and repeated them out to multiple servers. It did solve a few problems, but it wasn't really at the scale that we needed to truly solve 80% of the cases for how you're going to run your containers. In the summer of 2016, at DockerCon 2016, actually, Docker announced SwarmKit, which was a set of libraries or a toolkit related around a whole bunch of new Swarm features, and then they stuck that right in the Docker server. All along in this course, you've actually had the features available to you in the CLI and on your server, and now we finally get to dive into them. In January of 2017, 1.13 came out, and of course, because Swarm Mode was new in 2016, they're going to continue to make it better in the years to come. So in January, they added additional features called stacks and secrets, as well as other bonuses we'll talk about later. And it's important to note that Swarm is not actually enabled out of the box. In fact, on your machine, you couldn't use these commands listed here right now. They would actually give you an error because Swarm has to be enabled. And that was one of the design goals, was that none of the Swarm code would affect the existing Docker daemon, and that all the tools and systems out there that were already relying on Docker, or maybe they had their own orchestration on top of Docker, would continue to function and not be interfered with by Swarm now being a part of Docker. So some really basic concepts before we start diving in is that these blue boxes you see up at the top are what we call manager nodes, and they actually have a database locally on them, known as the Raft database. It stores their configuration and gives them all the information they need to have to be the authority inside a Swarm. And so what we have here is 3 different managers that have all been added to the Swarm, and they all keep a copy of that database and encrypt their traffic in order to ensure integrity and guarantee the trust that they're able to manage this swarm securely. And below in the green, we actually have worker nodes. So now you can see in the concept of swarm, we have now managers and workers. Each one of these would be a virtual machine or a physical host running some distribution of Linux or Windows Server. This is showing how they're actually all communicating over what we call the control plane, which is how orders get sent around the swarm for taking actions. And in a little bit more complicated view, we have this Raft consensus database I mentioned that is replicated again amongst all the nodes. They issue orders down to the workers. Now, the managers themselves can also be workers. And of course, you can demote and promote workers and managers into the two different roles. So when you think of a manager, typically think of a worker with permissions to control the swarm. And again, the only requirements for each one of these servers is that they're running the same Docker that you're already using now. With this concept of a swarm and these managers, we now have new concepts of what our containers look like. And so with the Docker run command, we could only really deploy one container. It would just create a container. It was always on whatever machine the Docker CLI was talking to. That's usually your local machine or maybe a server that you're logged into. But that Docker run command didn't have concepts around how to scale out or scale up. And so we needed new commands to deal with that. That's where the Docker service command comes from. And in a swarm, it replaces the Docker run command and allows us to add extra features to our container when we run it, such as replicas to tell us how many of those it wants to run. And those are known as tasks. A single service can have multiple tasks, and each one of those tasks will launch a container. So in this example, we've created a service using Docker service create to spin up an Nginx service using the Nginx image like we've done several times before. But we've told it that we'd like 3 replicas. And so it will use the manager nodes to decide where in the swarm to place those. By default, it tries to spread them out. So each node would get its own copy of the Nginx container up to the 3 replicas that we told it we needed. This is a quick and basic understanding of how the managers work and what they're doing in the background. And all these features are new. It's not simply just taking your command and running it on an API like we would experience with a Docker run command. There's actually a totally new Swarm API here that has a bunch of background services such as the scheduler and the dispatcher and the allocator and orchestrator that help make decisions around what the workers should be executing at any given moment. And so the workers are constantly reporting into the managers and asking for new work. The managers are constantly doling out new work and evaluating what you've told them to do against what they're actually doing. Then if there's any reconciliation to happen, they will make those changes, such as maybe you told it to spin up 3 more replica tasks in that service. And so the orchestrator will realize that and then issue orders down to the workers and so on. So with this swarm mode, we actually get a feature-packed set of capabilities out of the box that allow us to already use the existing Docker skills we have in order to deploy our containers to the internet in a reliable fashion and solve a lot of problems that we would have once we go production. All right, so wherever you're running your Docker from, we can actually create a single node swarm for our own testing purposes. The way I can tell whether swarm is on or not is I can just do a Docker info, and you'll notice swarm inactive. So we know that swarm hasn't been enabled here. And again, by default, Docker does not enable any of the swarm features. And I can run a Docker swarm init for initialize. And that took about a half a second. And we're done. What we have now is a single node swarm with all the features and functionality that we get out of the box. Okay, so that was probably the shortest demo of this entire course. So, I mean, what just happened? Like, we typed one command and magic. It wasn't actually any magic. It was a lot of very quick and efficient things in the Go programming of Docker, but essentially, right out of the box, it does a bunch of PKI and security stuff. So it creates a root certificate for the swarm that it will use to establish trust and sign certificates for all nodes and all managers. And it will create a special certificate for this first manager node because it's a manager versus a worker. And then it creates these tokens that we can actually use on other nodes to join this swarm. And then a bunch of other things in the background where it enables the Swarm API and creates something called the Raft Consensus Database, which we'll talk about later in a production part of the course. But just so you know, Raft is a protocol that actually ensures consistency across multiple nodes, and it's ideal for using in the cloud where we can't guarantee that any one thing will be available for any moment in time. It creates that database on disk, it stores the configuration of the swarm and that first manager, and it actually encrypts it, assuming you're on version 1.13 or newer. Then it'll wait for any other nodes before it starts actually replicating the database over to them. And again, all of this traffic that it would be doing once we create other nodes is all going to be encrypted. And one of the key components of Swarm that differentiated it when it first came out was that we didn't need an additional key value storage system or some database architecture to be the backend configuration management of our Swarm. And if you've been around the industry for years or decades even, there's this concept typically of the config DB, which is this separate database system that you usually need to make redundant that will store all the information about your orchestration and automation system. But Swarm has actually built that straight into Docker, right into the daemon, and handles it for us. So we never really need to do anything. There's no passwords to worry about. There's no special services to start up or anything like that. Okay, so back to the command line. You'll notice here that it talks about if I want to add a worker to the swarm, I just really need to cut and paste this onto the other servers I would add. Now later, we're actually going to build a multi-node swarm, but for now, we're just going to keep this at a single node. And let's take a look at a couple of the commands we'll get out of it. So first thing is we can do docker node ls. And in this case, we're just seeing the one manager node that we've created. You'll notice that it's marked as leader. And there can only be one leader at a time amongst all managers. And again, since we only got one, then obviously it's the leader. And we can look at help to see what other options we have here. And really the nodes commands used for bringing your servers in and out of the swarm or promoting them from workers to managers or demoting them from managers back down to workers. And if we go back to the docker swarm command for a little bit, we'll notice that it actually is a very narrow scoped command. It really is just to initialize, either join or leave, and the new unlock command, which we can talk about in a later lecture. For now, let's focus on the exciting new Docker service command. So again, service in a swarm replaces the Docker run. And I don't know for a fact, but I really think that this was centered around the idea that we didn't want to break existing Docker run functionality. But Docker run was always built from the ground up as a single host solution. Its whole idea was to focus on local containers on the system that it's talking to. Whereas when we start talking about a cluster, we don't care so much about individual nodes. We don't actually probably name them, and we treat them like cattle, if you've ever heard of the pets versus cattle analogy, where they're just a number and we don't really individually go to each node and start up an individual container. We really just throw requirements at the swarm in the form of services, and then it will orchestrate how it needs to lay all that out on which nodes they need to be, and we just know that it's got our back. Docker service create is how we give it some new orders. And let's do something really simple. Let's just actually have it start the Alpine image. And then we're going to have the Alpine image just use ping to hit 8888, which is actually a Google DNS server. But we really just want to give it something to do while we investigate what happens. And then you'll see, like Docker run, it spits back an ID. Only that's not the container ID, that's actually the service ID. And you'll see that we now have one service listed, just like with our Docker run command, since we didn't name it, it gave it a random name. And we can see that it's actually already spun up the one of one. And when you're looking at services, you're always going to see this number with a slash in the middle. And that represents the one on the left is how many are actually running.
and the one on the right is how many you've specified for it to run. So the goal of the orchestrator is to make these numbers match, whatever that takes. But this again doesn't actually show us the real container. This is really just showing us a list of our services. So we can drill down a little farther and we do a Docker service PS, and then we give it the name or the ID of the service, and that will actually show us the tasks or containers for this service. And you'll see that it's similar to the Docker container ls command, but it actually has now this node component, because when you're dealing with multi-server scenarios, we might need to know which server it's actually running on. And you'll notice that it actually gave it a name of an increment on the service name. So if we went back to the Docker container ls command, that still works. But in this case, the orchestration of Swarm is actually adding some information to the names and to the actual images that are running. And we'll cover some of those subtle differences later as well. But for now, let's actually take that service and let's scale it up. For that, we use the Docker service update and then the name of our service or the ID. In this case, I'll do the ID. And I want to change an attribute about the service. And in this case, I want to change the number of replicas. And so if we do a Docker service ls again, we now see 3 of 3. If we do a Docker service PS, we actually now see 3 tasks. And you'll notice that 2 were just created seconds ago. Now, if we were fast enough and if we were deploying something big enough, we could actually run the service ls and actually see it show us 0 of 3, 1 of 3. It'll actually increment as things start up. But it just so happens that Alpine was already on this machine in terms of its image, and it didn't take very long to start up a ping command. So we just couldn't be that fast. Now, what's interesting about that update command is that you can imagine the difference between the Docker run command that you might use on a single dev or test server or on your local machine, and the production concerns of always keeping something available as much as possible. And that's one of the design goals of Swarm. A command that we actually haven't used yet is the Docker update command. And that was a command for the Docker run containers that allowed us to update certain variables on our running container without having to kill it and restart it. And almost all of those options are related to limiting and controlling resource usage for that container, because that's one of the typical things that you see when you're running a long-term application, is that you need to change its resources, maybe because the databases have gotten bigger and need more RAM, or maybe you have a out of control process that's eating up too much CPU and you need to limit it. But if we do a help on the Docker service update command, you'll see that we have a lot more options, because the goal of a Swarm service is that it's able to replace containers and update changes in the service without taking the entire thing down. So if you had a service with 3 containers in it, you could technically take down one at a time to make a change and do sort of a rolling update, which is the blue-green pattern we talked about. And that's why we see a lot more options here, is because we can change these options that may require a container restart, but the Swarm will intelligently make sure that the way we update them is in a pattern that ensures consistent availability. Okay, so back to our Docker container list real quick. You notice that we have these 3 now, and what if I went in and sort of as a rogue did a Docker container rm and I specified one of these containers and I forced it. Let's say I beat the first one and I just take it out. All right, now I do a Docker service ls, and you see how it shows 2 of 3. So because I went in behind the back of Swarm and I actually took away a running container, it's going to identify that and it's going to launch a new one within seconds to replace the one that went down. And so if I did a Docker service PS on Frosty, you'll see that it actually shows the history of the first task here in the list, is that it had one that failed and it started a new one 24 seconds ago. And this is one of the responsibilities of a container orchestration system, is to make sure that the services you specified are always running, and if they fail, it recovers from that failure. which is way different than Docker Run, right? Docker Run would never recreate a container. And so that's why whenever we do any of these Docker service commands, we're not actually speaking directly to an action like create a container. We're actually telling an orchestration system, hey, put this job in your queue, and when you can get to it, please perform the actions on the swarm that I've asked here. And that's a big difference. It's subtle in the command line, but it's a big difference because it means that there's rollback possibilities, there's failure mitigation, and a lot of intelligence built into that. So in this case, if I actually wanted to remove all these containers, I'd have to remove the service. So I have to do docker service rm and then the Frosty. And now if we do a docker service ls, we see nothing. If we do a docker container ls, we see 3 containers. Oh, and there we go. That shows right there the automation happening on the back end. We were able to quickly show that we deleted the service, but the orchestration system hadn't gone through all of its processes of cleaning up the service and the tasks behind it. These concepts should be pretty easy to understand because they're just really expanding on the Docker Run concepts that we've had earlier in this course. So next, let's actually build a multi-node swarm and start scaling our containers out.